Hello, and welcome to Chemistry with Mr. Olson. Today we're going to do a gas law stoichiometry problem, which is very similar to regular stoichiometry, except it involves gases also. So we'll see. Take a look at this diagram. Grams to moles to moles to grams. That's our regular stoichiometry, and we know that at the heart of it, we go from moles of one thing to moles of another, from moles of X to moles of Y, using the mole ratio from the balanced chemical equation. Now, with gas law stoichiometry, we also may go from moles to liters of a gas using either, if we know we're at STP, then we can use that conversion factor, 22.4 liters per mole for any gas at STP. Or if we're not at STP, then we have to use PV equals nRT. All right, let's take a look at our problem. I've partially set it up here. This problem, we are reacting ammonia with oxygen to form nitrogen monoxide and water. And this is the balanced chemical equation. Balancing it is a lot of fun, especially if you use the fraction method. But this is the end result. And at STP, what volume is needed to burn 15.0 liters of ammonia? So this is the question we're going to answer. And like other stoichiometry problems, it's a given times conversion factors problem. And I've already written the given. And we're going to need 3 conversion factors. We need to get to moles so that we can use the mole ratio. Our question gives us ammonia and asks about oxygen. So we need to use the fact that in the balanced chemical equation, for every 4 moles of ammonia that we react 5 moles of oxygen. Okay, so let's build our conversion factors. We have to get to moles. And we're at STP, so we know there's a conversion factor that we can use. It's right on our reference sheet, 22.4 liters per mole for any gas at STP. And so, out of liters of ammonia into moles of ammonia. And the numbers that make this a valid conversion factor, every 1 mole, 22.4 liters. Now that we're into, of course, these units cancel. That's why we set it up that way. And we're ready to get out of moles of ammonia into moles of oxygen. So a next conversion factor relates those. It's the mole ratio. So we write moles of ammonia here on the bottom, and on the top, moles of O2, because that's what we want to convert to. And the numbers come straight out of the balanced chemical equation. 4 moles of ammonia react with 5 moles of oxygen. Now, the moles of ammonia cancel, and we're into moles of oxygen. It's very clear we need to write moles of what? I see some students writing just moles, and you're left asking, moles of what? What are you talking about? All right, now we're into moles of oxygen. We're almost done, but we don't want moles of oxygen. We want the volume of oxygen, which is measured in liters. So, can we get from moles to liters? Yes, because we have that same 22.4 liters per mole conversion factor. So, out of moles of O2 into liters of O2, 1 mole is 22.4 liters. Because we are at STP. At STP. Okay. So these units cancel. Choose a different color. Moles of O2 cancels moles of O2. The only unit left is liters of O2. That makes us happy because the question asked what volume of oxygen. That's liters is volume. And we do the math and come out with an answer of 18.8 liters of O2. Box our answer, and we've got it. Let's see. Let's get that answer on the screen. Okay. So that's how we do gas law stoichiometry. As we saw before, grams to moles to grams, except we can go from grams or from moles also to liters. At the heart of it is the mole to mole ratio in the balanced chemical equation. And a very useful fact, if you're at STP, then you know it's 22.4 liters per mole, and you can use that to go directly from moles to liters or liters to moles, and that is gas law stoichiometry. Have a beautiful evening. Ta-ta.